Hello everybody, I am Cadet Corporal Madeline Lorraine Miller from Company G1, Go Greeks. Today we are going to solve a conservation of momentum physics problem. Let's read the problem, shall we? A group of spirited Greeks went on a spirit mission to blow up the Root Hog mascot of rival H1. The Root Hog is at rest at the origin of an XY coordinate system and explodes into 3 pieces. Just after the explosion, one piece of mass m moves with velocity negative 44 meters per second in the x direction, and a second piece, also of mass m, moves with velocity negative 44 meters per second in the y direction. The third piece has mass 4m. Just after the explosion, what are the a magnitude and b direction of the velocity of the third piece? Alright, number 1 of the problem-solving process on your handy-dandy physics reference card is to read the problem, which we just did. The next step is to outline the task, which is pretty easy because it says right here what the task is. So in this problem, we are going to calculate for A, the magnitude of the velocity of the third piece, and for part B, we are going to calculate the direction of the velocity of the third piece. Alright, our next step on our physics reference card in the problem-solving process is physics. And in this problem, we are going to be doing conservation of momentum. So now we are able to draw a picture. So in these types of problems, we're going to draw a before and an after picture. So our before picture, we can see that the mass initial is just going to be, it's going to be still. And the after picture, that is when it explodes. So there's going to be 3 pieces here moving in different directions. So we know that mass 1 is moving the negative x direction if we define our axes here. And this is V1. Alright, mass 2. It is moving here in the negative y direction. We'll call this V2. And that leaves us with the third piece, which we're trying to solve for, which is going to be somewhere moving in this general direction. So now we will list our givens. So we know that M1 is equal to M2, and we're just going to call that M. We also know that the initial velocity equals 0 because it's at rest. Velocity of the first piece we can see is negative 44 meters per second in the x direction, which we will just call I hat. Velocity of the second piece is negative 44 in the y direction, which we will call J hat, meters per second. And we also know that the mass of the third piece is 4m. Okay, we are going to make our assumptions now. And we will assume that this is a closed system. So now we have everything laid out and we are ready to solve the problem. It's very exciting. Okay, we are going to use the equation sum of p, and p is momentum. So sum of P initial equals sum of P final. And we'll also use the equation P equals mv. And you can find both of these on your physics reference card. So the first thing to do is to resolve into the x and y components. So for part A, the mass initial, velocity initial in the x direction will equal mass of 1, velocity of 1 in the x direction, plus mass of 2, velocity of 2 in the x direction, plus mass of 3, velocity of 3 in the x direction. So we can cancel some things out right now because we know that the velocity initial is 0 meters per second. We also know that the velocity in the x direction of the second piece is 0 because this is only moving in the y direction. So we can clean this up a little bit, bring the third block to the other side. And we're trying to solve for v3 in the x direction. So we'll divide by the mass of the third block, which is negative. All right, and that will give us negative 44 meters per second over negative 4. And the m's cancel out because it's going to be m here and m here. So those will just cancel out. And can't forget about these negatives too, because these negatives are going to cancel out as well. And this is going to equal 11 meters per second in the I direction, I guess x direction. So going along with this, we also need to resolve in the y direction. So it's basically the same thing, but instead of having x's there, we will have y's. To velocity in the y direction, mass, velocity, third piece in the y direction. So we can also cancel some things out in this one. It's going to be the same thing. The velocity of the initial piece is going to be 0 in both the y and the x directions. And we can cancel out the first block in this piece as well because it's only moving in the x direction. So cleaning this up, it's a very similar process. We'll bring this over to the other side. v3y equals m2v2y. We're going to solve for the velocity of the third piece in the y direction. So divide by mass and v3y. That will equal actually the same thing. And remember, the m's cancel out from 4m here and just m up top. So this is going to end up equaling 11 meters per second in the y direction. All right, so we're going to continue this up here because we're not done yet. So right now, we know that the velocity of the third piece is 11 meters per second in the x direction plus 11 meters per second in the y direction. To find the magnitude of the velocity, we are going to do this. Velocity. We will take the square of the x component plus the square of the y component, and we're going to square root that sum. It's going to look like this. 11 meters per second squared plus 11 meters per second squared. And this equals about 15.5. And we know that in our problem, they give us numbers with two significant figures, so we will have our answers in two significant figures as well. 16 meters per second. So that is our answer for part A. All right, so now we go on to part B, solving for the direction of the velocity of the third piece. So general direction is probably somewhere right here, because we know that we have a piece moving in the negative x direction and the negative y direction, so to even things out, it's got to be somewhere in between going in the positive direction. So this will be our theta, and we're going to use trig to solve this. And this is, we have our axes here, this is v3x and v3y. So we know both of these. We solved for them right here. 11 and 11. So let's see. Compared to our angle, this is the opposite and this is adjacent. So whatever is opposite and adjacent that you know, you can use tangent. Alright, so we will do that. Tangent theta. And it's opposite, and the y side is opposite from theta, and the x side is adjacent to theta. And that will equal tangent, this is 11 meters per second over 11 meters per second. And this just cancels out to 1. And tangent, -1, this is going to equal theta. Tangent 1 is 45 degrees, and it's going to be above the x-axis. So this is our answer.